Hello, students, and welcome to today's lecture where we are going to be talking about concentration and also going over a little bit of story time. Okay, and this story time that we're going to go over here is kind of one of the reasons why you should know your concentrations, because even when you become a chemistry teacher or even any other type of teacher or any place that you have to deal with chemicals, sometimes you're going to notice that a lot of people are uncomfortable, in particular, with making concentrations. So that's why I'm going to go ahead and tell you guys the story of what I'm going to go ahead and call the Great Acid Shortage. And this all happened in 2015. Okay? So I want you to imagine that Mr. Bradley here is a brand new teacher, and he comes to Colonial, and he's all excited, and he knows his chemistry, and he's like, yeah, I'm going to go ahead and, help students, and I'm going to go ahead and get to play with chemicals and all sorts of things like that. And when I came, I noticed that there were a couple of things. First, the back room was just an absolute disaster. Where all the chemicals was, it was a disaster. The second was that we had no acid in the back room. But every single teacher had their own containers of acid. And what had been going on is that nobody in the chemical department at the time was willing to work with really strong concentrated acid. So typically when I buy acid, what I'm going to do is I'm going to buy a concentration that's like super, super concentrated, okay? And I'm going to work with like 15.0 molar acid, okay? And this is going to be our acid here. And this is the stuff that's like really super dangerous. This is the stuff that if you leave it sitting on your counter, like it'll make acid fumes, and like nobody wants to work with this because it's super concentrated acid. And a lot of times, in this particular case, the chemist did not want to go ahead and order it. So what they had done was that they had kept taking their regular acid amounts, and they like to put it into 1 molar acid, okay? So they had only ordered 1 molar acid. And what had been happening is, since they were unable to buy more of this 1 molar acid, they had just been making more and more bottles of less concentrated acid. So gradually what happened was that they would take their 1 molar acid and they would dilute it with water, and soon they'd have 0.5 molar acid. And then soon, after a while, they would realize, oh, wait a minute, I'm almost out of my 0.5 molar acid. Better make it even worse. Oh, I'm almost out of that. I'll make it even worse. And they kept diluting it down and diluting it down and diluting it down until eventually they gave up on saying what the concentration was, and they ended up saying that it was just dilute hydrochloric acid. And as you guys can imagine, for like a chemist like me, seeing that there was only dilute hydrochloric acid all over the place and that everybody had like their own concentrations, I was pretty upset. I was like, what? This isn't how we do science. This is bad. So I ended up taking over the storeroom, and then I ended up getting rid of all their dilute hydrochloric acids. It took many years, and I had to like steal it from all the classrooms, and gradually we have a back room now where we have like the actual strong stuff. And so today's lesson is really kind of going over how we can make sure that we dilute a strong acid into a weaker one. And we're going to be learning the math process for how we do that. And it's actually going to be a really simple problem for us to go ahead and work with, okay? And the really simple process is that we're going to use this formula, and this is like our dilution formula, okay? And sometimes you'll get questions where they have you, try and make a more concentrated one somehow. But in general, what's going to happen is that you're going to take your concentrated acid, and that's going to have some molarity, and that's going to be our first molarity. And then you know that to make a less concentrated one, you're going to need to have some volume of that, okay? And the molarity times the volume is going to end up equaling the molarity times the volume of the dilute solution that you want, okay? So typically when I do a lab with students that has acid in it, I'm not giving you guys the 15 molar face melting acid, okay? I'm going to give you something that's a little bit more dilute, for many reasons. Safety, and, you really don't need to have that concentrated of an acid, okay? And we'll go ahead and go over a typical procedure for how I end up making the more dilute acid right here, okay? So as I said before, the concentrated acid that we're going to use is 15 molar, okay? And we're going to go ahead and say, all right, I am doing a lab, okay? And we're going to go ahead and say that it's for 5th period, okay? And 5th period needs a total of 500 milliliters of 1.0 molar acid, okay? So we're going to make our lives really easy, and we're going to say that 5th period, I need to make 500 milliliters of 1.0 molar acid, okay? Easy, okay? So I know that the dilute acid is going to be 1.0 molar. And I know that the volume that I need is going to need to be 500 milliliters. Okay. From here, I know that my concentrated acid is 15 molar. So I'm going to go ahead and say, all right, well, how many milliliters of my 15 molar do I need to add to water in order to get this concentration? So I'm going to go ahead and put an X right there because I need to figure out how many liters, or milliliters in this case, how many milliliters of strong acid I need. So I'm going to go ahead and now isolate this X, and it's fairly easy. I have 15 molar over here, so I'll go ahead and move X equals 1.0 molar times 500 milliliters. We'll divide this by 15 molar. So we'll go ahead and do our math here. 1.0 times 500 divided by 15. And it looks like we end up needing 33.3 milliliters of our strong acid. Okay. And that's all that we need to do for this particular type of problem. Okay. It's just plugging in the information that we're given, and knowing which one's our strong one and our dilute one. Okay. So let's go ahead and do another practice problem here. Okay. And let's say that we're working with H2SO4. Okay. H2SO4 is another really, really strong acid. It's known as sulfuric acid. And sulfuric acid, it comes in a concentration of 14.7 molar solution. So that's 14.7 moles per liter. Okay. And let's say that we're doing a lab where we need, we'll go with 0.75 molar, okay? We'll put moles over later here, okay? And let's say that in that lab that we're going to need to have 250 milliliters of it, okay? Well, we'll go ahead and be like, well, I know that my formula is M1, okay, molarity of the strong acid, times the volume of the strong acid, equals molarity of the dilute acid times the volume of the dilute acid. This is the molarity of the strong acid, so 14.7 molar. Volume, well, I don't know how much I'm going to have to use. I hope it's not a lot. This molarity is going to be the 0.75. This volume is going to be the 250 milliliters. We're going to go ahead and isolate our x. We want our x to be all alone and lonely. And we will have 0.75 times 250 divided by 14.7. And it looks like to make this, we will only need 12.755 milliliters of H2SO4. All right. And that's really it for today's story time and lecture. Okay. I hope you've enjoyed today's lecture, and remember, stay lazy.